Hey, good evening, Sarah. I have a few time before I have to run and pick up one of my girls. Um, I'm realizing my computer is getting dead. Put some charge here. Okay. So we were talking before about folding light curve, and I decided to create a little exercise that show you what I mean by that. And to do that, let me show something quickly what I did. Um, so I will generate, see if that makes sense. I will generate a perfect sinusoidal light curve. And let's say there is a perfect star that do a perfect sinusoidal variation in its light curve. And I will observe this star over a period of, let's say, 100 days. But I'm not going to go there every day. I'm going to go start today, or tomorrow I'm going to do again, and then 3 days I will do, and then 20 days from now I observe again. And then if the star is perfect, if everything is perfect, all these data points will fall in this perfectly sinusoidal light curve. So what we're gonna do, I will generate these days, an array that represents the days, and then I will create a perfect sine function, and I will plot this so we see what's going on. And then I will call a routine that I just sent to you called n-pergram periodogram. New, I think this is a routine that we used before. I found in my old machine, and it works fine. But there are more robust algorithmic to find periodicity now, especially in the data we have. I think we have to be a little bit more clever. And I think our wizards, Ognian and Vikas, might be able to help us on that because they might have the resources to do that. So then we're going to see this plot done, and then I will submit that data, which means the observations, fake observations we did on the days we did. I will feed this routine, and this routine will try to give us, okay, the period that you have here, the most probable one is such and such. Okay. Next step would be to fold this light curve, and I have to work on that. But I think I have to stop work pretty soon, and I would like to send this to you. So if you have the time, you can work before the meeting tomorrow on Thursday. So we can, if you could submit your data to this routine, that would be good. So let me show you this. I hope you can see my screen. I think you can, right? Yeah, so you're sharing. So I have here a array that is in double precision. I'm not there yet. In fact, let's generate this from the beginning. So I'll create an array called days, right? That, okay, I observe today, in fact, a double precision. I observe today, tomorrow, 3 days from now, 10 days from now, 15, 25, 36, 47, then 50, 54, 56, 68, 78, 88, 89, 9, 9, no, 91, 93, 95, 100, okay? So those are the days that I hypothetically observe this fine star. So let's come up with a period. Period is, I don't know, 3 days. Let's say the periodicity is 3 days. But just to be without suspicion here, let's put, I don't know, 3.25 days. So for a period of 3.25 days, the frequency is 1 over that. right? 1 over the period, right? And the omega, or the angular frequency, is 2 times pi, and I will put a double precision pi, 2 pi f times the frequency times f. So that's our omega, okay? So our function, our light curve is going to be given, light curve is going to be given by a sine function of omega times the days we observe, omega t, right? So, but t is the days that we did observation, is my double precision array. Okay. So I have now my perfect star. I have the days I observe, and I can plot days. I can plot days and light curve on a symbol equal to. See what I got. I got nothing. Oh, wait a second. I think I have some problem. Okay, I'm doing it again. There you go. Take my face from here. So this is what we get. Can you see any periodicity here? No. So we don't know, right? So it's all confused. I can even connect the data points, and that's what we got. Now let's say that I observe not, put back like this. Let's say that I observe this perfect star not with that sparse or scattered days, but I observe a lot, right? And I will create now another frequency of observation. Let's say I have a space telescope with many days. It's going to be a double precision array. So IndiGen is a routine that gives you a series of integer. For instance, if you put IndiGen 10, it's going to give you 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I put IndiGen 1000, right, it's going to give me an array, integer array, that goes from 0 all the way to 999 points. So let's say that I observed this same perfect star 1,000 times, right, equally spaced, and exactly what would be my light curve if this type of thing happened. So let me show you that. So I take this array divided by 1,000, right? I divide by 1,000 and then multiply that by the number of days that I observe. So I observe what? 100, right? All the way to 100. So I'm going to put 100 here. And so I have many days. Oops, something's wrong. Oh, no, it's not double. Okay. And I will create now an O plot. I overplot now these many days observations, and the light curve would be sine, right, of omega times these many days. And now I'm gonna color that with some nice color. So see what happened now. So if I had observed this perfect star with a lot of data points, with a perfect cadence, see that all these points that I have here would fall in a curve. You know what I'm trying to show you? So basically, although just by looking at the stars dots I have in the plot, this doesn't tell us what period that is. If I can look at this red display, I know the period. See, the period here, so which means this peak repeats itself with a frequency that is equal to the period that I gave, is 3 days, right? Isn't that 3 days? What's the period? The period was 3.25. So I could, for instance, even do like this. Plot, instead of plot, I'm gonna plot with a range just 0 to 6, let's say. Right? So this is the red curve that I'm now expanding in 6 days. And then you can see that it's repeating itself. This is 3.5 right here, right? So the curve we had before, this one and this one, is curve in red is the one that I just showed now, but it's all expanded. And then you see that the dots are actually appearing there. So if I plot many days and I plot the other one, oops. Now you can see the dots appearing over there and here. That's where they're appearing. See, and another one there. So I have 1, 2, and 3. So what you have into Double Hydra in those scattered points, you have points, but we can't see the period. So we have to submit these points to a routine that can do a search in frequency. So what these routines usually do, they do a Fourier transform, and they find the peak in the transform function, and I really would like to remember how this is done. I really don't. I have to review my books, but it gives you an option or a range of frequencies, and then you can see if they are reasonable or not. That's what we did in the past. So then let's do that. I would take our days. I would take this sequence of points here, and I submit to any period, any periogram. Let me show you here. There you go. Periogram, days, sine of omega times days, which would be a light curve, right? So I want a light curve. Light curve. So this routine, you have to input the days, which means in your case in TW Hydra is the Julian date. The light curve is your veiling, right? During those days that we select or we extract. Nu is, I think is the, yeah, I think nu is going to be nu is the period in frequency. And then it has the amplitude of the periodogram, has a few things here which I don't remember today, but if you put that up, it gives you a result. And it has an option of periods here. So, and then it finds reasons. So the period that we input was 3.25, and it finds the most probable one with a false alarm probability of 1%, no, 1 in 1,000 to be right, to be wrong, I mean. So that's a good one, 3.5. And that's what is being shown here. So that's the power the period in days. So I do a search in various possible periods, and the one that gives a higher power is the one at this particular day, and that is the one that is listed here. So the next step would be to take this period now and feed your light curve, and then fold this light curve in that period. And I don't think I saved the routine. I don't have it, but we can develop that quickly. In fact, after I stop taping these and send this to you, I will work on it. If I don't sleep before, I have that done. Okay, so that's it. I'll send this file to you.